Alright, good evening everyone. I am going to be teaching this evening Venn diagrams. So hopefully by the end of this evening you will understand this topic really well. There is some memory work to do, so you really do need to pay attention. But I'm going to go through everything you're going to need to know, and hopefully by the end you'll be much more up to speed with it. So first of all, a little bit of terminology. Venn diagrams are a way of graphically representing statistical problems. And you can see here a box with two groups, A and B. The letter E that you see here is the universal set that represents everything and everyone. Everything, all elements, must be contained within this rectangular box. A and B are groups then within the universal set. Okay. So, if an element is going to be in set A, it could be anywhere inside the green circle. And if it's in set B, it could be anywhere inside the red circle. Okay. Trying to think of an example where you would understand that. Let's say that E was the numbers between 1 and 15. Then A was multiples of 5. You would find 5, 10 and 15 inside the circle A. And if B were multiples of 3, you'd have 3, 6, 9, 12 and 15 inside the red circle. And then there would be some overlap. 5 times 3 is 15, so 15 would be in the middle. But you get the point. It depends on what you define the universal set to be for what is going to be inside the groups. So this is where it gets a little bit more tricky, and here is where the memory work comes in. A with an apostrophe means A not. So if an element is not in set A, it could be anywhere else inside the universal group. But it could not be inside the circle A. And B not cannot be anywhere inside the circle B. It can be anywhere else. So I'm just trying to get you used to the terminology that is used with these Venn diagrams. So if it's in A, it's going to be inside the green circle. If it's in B, it's going to be inside the red one. If it's not in A, it can be anywhere else. And if it's not in B, it can be anywhere outside the group B. So here's where some learning comes in. If we have A union B, A union B is anywhere inside either A or B, and it's the binocular shape that I've drawn in here. Okay, it means in A or B or both. And then A subsection B, A naught subsection B naught is going to be anywhere outside of A or B. So it's in many ways the opposite diagram to this first one, but you do need to know what A union B means, and it's anything inside both of A or B or both. And A naught subsection B naught is anywhere outside either. So I'm going to just extend the page so you get a chance to see that picture a bit better without my head in the way. There we go. Okay, good. Let's move on. A subsection B is the overlapping section between the groups A and B. So whereas A union B was everything inside of A and B, A subsection B is kind of like what's common in both. Okay. It's one of the ones you have to learn, and it's well worth knowing that one. Then we have A subsection B not. A not B. This means everything in A but not in B. It's fairly straightforward, but it's again remembering what that symbology means. A subsection B not. Okay, I'm going to again extend the page so you can have another good look at that picture. A subsection B not. Moving on, we have A union B not. Okay, now this is a composite. Well, I'm going to explain it with a composite. It can be built up using two Venn diagrams. The first one is everything inside A, which is this green circle that I explained to you first. And then if you're looking for not in B, it's everything outside of B. And if you add those two pictures together, you will get A union B not. So there is a slight overlap into B from A, because everything inside of A is allowed. But that part of B will not be allowed. Okay. Lastly, we have A subsection B all knotted, and this is the inverse or opposite of A subsection B. So if you remember, A subsection B was this picture on the right. It was what the overlapping section of A and B. So if I want A subsection B not, it's everything else on the outside of that subsection. Let me just try and get that in view so you can see it. My head's in the way again. Scroll down the page very slowly. Okay, maybe I can try and duck. A subsection B not is everything other than A subsection B. So these pictures are well worth learning. Either screenshot your computer or download the notes for this lesson, and you'll be able to learn those pictures inside out and back to front. And they will help you for the exam, because you need to know which ones are which.
Right, going to go through an actual question with numbers now. Amongst a group of 24 students, 12 are doing maths, 10 are doing biology, 5 are doing neither. How many students do both math and biology? Also, what is the probability that a random student does biology? So, we have to pick out information from the question, and I'm going to get my highlighter pen. And the first piece of information is this: amongst a group of 24 students. So that is telling us that the universal group is 24. Then we have 12 are doing maths and 10 are doing biology. Ooh, that's a bit wonky. Let me erase that. So I'm going to change the lettering here from A and B. Let's have a quick look at the group. There we go. We'll change A to M, and we'll put 12 in. And B for biology, that equals 10. How many students do both maths and biology? Also, what is the probability of a random student does biology? So, there are two ways of doing this. I'm going to show you the numbers way first, and then I'll show you the algebra way. So the first thing you have to do is hang on, sorry, I missed a piece of information. The piece of information I missed is that 5 are doing neither. Okay, so let's put that in as well. n equals 5. So the first thing that you have to do for this is to work out what M union B is. Now remember from the pictures, that's the sum of everything in both circles. Well, it will be the universal group E, which is 24, subtract 5, or 19. But it is also going to be 12 plus 10, because that includes all of the people who do both math and biology twice. So the difference between 22 and 19 is 3, and that 3 will go in the middle here. Then you can see in the math circle that 3 plus 9 will make 12, or 12 minus 3 if you think of it like that. And for biology, 3 plus 7 will make 10, or 10 minus 3 gives me 7. So that's one way of doing it, and we'll just check the numbers add up. So 9 plus 3 is 12, plus 7 is 19, plus 5 is 24, which makes it correct. I'm going to grab all of this again, and I'm going to start a new slide, drop it in, copy, paste. I'm going to show you the other method. So if I wipe this all off now, we'll start the same way. E will equal 24, and N equals 5. Let's move that down here. If you have something you don't know, we can label it with an algebra letter, which is X. Okay, so that's what I'm going to do for the overlapping section in the middle. And we should know that this part of the circle for maths will be 12 subtract X. And this part of the circle here will be 10 subtract X. Okay, so I've just represented the numbers there with missing algebra. And it should make sense if you've got any algebra knowledge what's going on there. So we'll just now add everything up. So if I do 12 minus x plus 10 minus x plus 5, that should equal 24. Make sense? So let's try and solve now for x. Well, x minus x plus x will cancel out. So let me get a line. This will cancel with this. And I've then got to subtract x on its own. But let's have a look at what we've got in terms of numbers. So 12 plus 10 is 22, plus 5 is 27. 27 minus x is 24. And you can very easily see there that x has got to be 3. that will allow you to put the x into the overlapping section, and 12 minus 3, 9, 10 minus 3, 7. Okay, so that's the other way of doing it. I've written the other method out here longhand, and you should be able to know this formula that A union B equals the whole of circle A plus the whole of circle B minus the intersection A subsection B, which is going to be counted twice when you add the two circles together. But that's well worth knowing, that formula. Good.
We're going to do another old exam question, which is on a more difficult problem: running, swimming, cycling, and doing all three. The following shows the results of a survey of the types of exercise taken by a group of 100 people. 65 run, 48 swim, 60 cycle, 40 run and swim, 30 swim and cycle, 35 run and cycle, and 25 do all three. Draw a Venn diagram to represent the data. Find the probability that a randomly selected person from the survey takes none of these types of exercise, swims but does not run, and takes at least two of these types of exercise. And then the last part is a more difficult question on conditional probability. I will go through it, but I think the most important part here is to be able to draw the Venn diagram and be able to generate the rest of the question for 10 marks. Okay, so running, swimming and cycling, we've got 3 circles now. 3 overlapping circles rather than 2. Okay, and we're going to do the same as we did before with the last question. We are going to pick off the information one piece at a time and then get the answer out. Okay, so the first piece of information is 100 people. So on this picture, the universal set will be 100. So I can tick that piece of information off. Then we've got run, swim and cycle and some numbers associated with it. So run is 65, so I can put in R equals 65. So that's the first piece of information. We've then got 48 swimming, so swim equals 48. And then the last piece of information is about cycling. And how many people cycled? 60 cycled. Let's go back to the picture. We'll tick off swimming and cycling. Then we've got 40 run and swim. So if I go back to this, I'm not going to put something straight on here. I'm just going to put it at the side. Run plus swim is 40. So that's that piece of information. Swim and cycle is 30. And then run and cycle is 35. Finally, 25 do all three. So if I go back in here, doing all three we can put in straight away. And it's going to be this middle section that all 3 circles occupy. I can put my 25 in there that do all 3 straight away. So we have just taken all of the information from the question and put it onto our Venn diagram. There's still a bit more work to do, but we're almost there. Okay, we're now going to get the highlighter pen and we're going to look at various things. The first thing is running and swimming, which we're told is 40. Now, running and swimming is this overlapping section here. Okay. So if you look at the circles for running and swimming, that is the piece that overlaps between running and swimming. So the total in that highlighted section must be 40, which means I can now fill in the gap. Get my pen again. 40 subtract 25 gives me 15. Shrink that up. Okay, let's get a different colour highlighter now. Let's go for a blue one, I think. And we're going to do swimming and cycling. So the overlap between swimming and cycling is this overlapping piece here. And for some reason, the blue has not overridden the green there, which is a bit of a shame. But it is still highlighted, and you can see that very gradually there. Maybe I can I try and bring this to front? Nope, it won't allow me to do that. Never mind. Okay, so I know the total for this overlapping section is going to be 30, which means I'm going to take my pen and I can do 30 subtract 25 will give me 5. Shrink it down, and then we need to do running and cycling. So this is the last overlapping part. Get my highlighter. We'll do this in purple this time. So this is going to be this section here, and for some reason it does overwrite the green now. Okay, so that's a bit of a mess in the middle, but the point is you can see what's going on here. If we know that the total for that overlapping part is 35, then 35 minus 25 will equal 10. Okay, I'm not going to shrink that down because we've fitted in correctly. So the last thing to do here is to fill in the rest of the circles. We know that for the running circle, that's the whole circle, the total is going to be 65. So I'm going to need to do 65 subtract, and I'm going to open a bracket, 15 plus 25 plus 10, and then I'm going to close the bracket. So it's easier to add all of the bits of information you know first in order to get the answer out that you're looking for. So 15 add 25 is 40, plus 10 will make 50. 65 minus 50 gives us 15. Next, we need to fill in the swimming circle. So for swimming, it will be 48 minus, open brackets, 15 plus 25 plus 5. That's going to equal, let's do the math, 15 plus 25 is 40, plus 5 will make 45. 48 minus 45 is 3. So that can go there. Lastly, we will do the swimming circle. So we know that the total is 60 for this circle. And 60 subtract 10 plus 25 plus 5 equals, doing the math again, 10 plus 25 is 35, plus 5 makes 40, 60 minus 40 gives me 20. So there's one more thing we have to do to make this Venn diagram perfect. We have to check that all of the numbers inside the circle add up to what number? They need to add up to the universal group, which is 100. If it doesn't add up to 100, then there are going to be people on the outside that don't do either running, swimming or cycling. Okay, this is the non-group. If they don't do running, swimming or cycling, then they don't appear in this Venn diagram. So we work that out by adding up everything that we've got here. So if we start with the running circle, we know that the total inside that circle is going to be 65 because it's been told to us at the start. If we then add on 3 from the swimming circle, that makes 68. We add on another 5, that will make 73. And then add on another 20 from the cycling circle, that will make 93. So I know that the sum of everything inside all 3 circles, running, union, swimming, union, cycling, is 93. Okay, maybe I make a note of that outside. So running, union, swimming, union, cycling equals 93. That means our n is going to be 100 minus 93, which gives 7. Okay, so that is now a fully complete Venn diagram, and it's a more complicated problem, but you need to know how to do it if you're going to be doing maths in Venn diagrams. So on the next slide, I have got everything written out properly in type. So I won't be saving this handwritten working on the final set of slides, which you can get from the shop. But that's the answer to the first question. Draw a Venn diagram to represent the data. Let's look at the second question then, probability of no exercise. So we've been through this before. The total people inside all 3 circles is 15 plus 15 plus 3 plus 10 plus 25 plus 5 plus 20, which is 93. So the probability of no exercise is 100 minus 93, or 7 out of 100, and that's gone a bit wonky. Let's see if I can gain access to this to correct the positioning of the hundreds. There we go, that's a bit better. Swims but does not run was the third question. So swimming but does not run would be this section here, which is just 5 and 3. So maybe I can highlight that for you if I get my highlighter pen. Let's go for a different colour. Let's go for yellow. So swimming is this circle, yeah, but does not run means that I cannot include anything inside the run circle, but I can include everything else, which I've highlighted. 3 plus 5 will make 8, so swim but no run is 8 out of 100, or 0.08. Let me now clear that. Let me get a rubber, big rubber. There we go. That's now clear again. Pens, and I'll go for a green this time. Takes at least 2 of the types of exercise involved. So we have to figure out what those 2 types of exercise might be. Well, we could have running and cycling. We could have running and swimming. We could have swimming and cycling. Or we could have all 3. So if we add up all of those things, running and cycling was 10. That's this bit. Swimming and cycling is 5. Running and swimming is 15. And then 25 is all 3. We add those numbers up, we'll get 55 out of 100. 55 out of 100 cancels down to 11 over 20. I'm sure I don't need to explain why, but I will go through that. In any event, 55 is the same as 5 times 11. And 100 is 5 times 20. So I can cancel the 5s on top and bottom, which will leave me with 11 over 20. Okay. So I'll just scroll that down so you can see page. Okay. 2 of these types of exercise, running and cycling, running and swimming, swimming and cycling, and all 3, 55 out of 100 or 11 over 20. Okay. Good. The last question was a conditional probability question, and this is where things get really tricky. Given that Jason runs, find out the probability that he swims but doesn't cycle. Okay. Conditional probability: swims, not cycle, but runs. Swims, doesn't cycle, but runs. So Jason has to be one of the 65 people that runs. This will be the denominator of the probability. Okay? If he must run, he has to be inside the running circle. Swimmers will be in the yellow section that I've highlighted above. So he could be one of the 15 or the 25 that does all 3. Okay. However, we want those who do not cycle. Thus, the 25 in the middle who do all 3 exercises must be excluded. Okay. So what I'm saying there is the 25, this part, he can't be one of those people. He's got to be one of the 15 that's in the yellow section. So the probability of swimming, not cycling, but running is 15 out of 65, and that will cancel down. If I scroll down, extend the page, it's going to be 15 out of 65 or 3 out of 13, because I can divide 15 by 5 and 65 by 5. Okay, it's the same thing as what I did on the previous slide, that 5 times 3 makes 15, and 13 times 5 makes 65. 5s will cancel, and I'm left with 3 over 13. Okay. Right, that is all I have on Venn diagrams. Thank you for staying with me for almost 40 minutes. I hope it's been helpful, this lesson for you. And stay tuned, I have some stuff coming up on compound interest formula, and I've got some slides on subnetting that I want to go through. So I know they're pretty random topics, but we will resume with those shortly. Hi everyone, this is a friendly reminder to like, subscribe and hit the bell notification icon to stay tuned for future videos on this channel. I also welcome constructive comments in the box below, and you can gain access to any of my teaching resources through the link above. If you'd like to support me through donation, you can either go to paypal.me/Jonathan Kipping or patreon.com/Jonathan Kipping. Stay tuned and look forward to future videos.